Data analysis types. So very broadly, we can conceive of two types of data analysis, the descriptive and the inferential. Descriptive data analysis often is used to diagnose problems or just to really explore the data and understand some of the basic patterns of the data, some central measures, some averages, the ranges of values, maybe how the values are distributed over time. You're doing some basic data visualization. And then there are the more sophisticated analytical processes of what is often called inferential statistics. And this involves things that other people have called predictive analytics, predictive statistics, or prescriptive, meaning that it can give you information about for decisions, what decisions one should make. It can also serve to be a diagnostic in the sense that you can understand what caused something else to happen. Essentially, though, all inferential statistics are about how one or more variables impact another or other variables. It really is learning about how, if you change one variable, how does that impact other variables? And what causes one thing to lead something to be one way, or what causes it to go another way? We'll explore these a little bit more. So there are a number of inferential and predictive models that are used in statistics and data science. So things like regression analysis, cluster analysis, naive Bayes neural networks. Other tools too that we don't talk about here, but you may be familiar with, like t-tests, other kinds of statistical tests that explore the significant variation in different kinds of data distributions. Some of the tools are the R programming language, the Python language and its associated libraries, SAP, IBM, Google Predictive Analytics, RapidMiner. There are lots and lots of tools out there for exploring inferential and predictive models, such as these ones here, and carrying out these kinds of inferential statistics and other analytical processes. Moving along into the data communication realm, so we're kind of finally getting here into the last dimension. Data communication at a human level, that is not at the technology network communication, is part of scientific, business, and social communication. And in general, goals of communication in these contexts are for persuasion, for understanding, for sharing information, for relating and connecting to others, and for informing decisions. There are different types of data communication in an organization. So we can think of upward communication. So when you're talking to a boss or people who are higher up, there's downward communication when you're talking to people sort of below you in the organizational hierarchy. There's lateral communication, talking to peers that are within the same department or hierarchy as you are. And then external communication, communicating outside of the organization. Methods of data communication include emails, telephone or video call, in-person meeting, reports, presentations, forum boards, internal publications, or external publications. And I think this includes pretty much all of the ways that a communication can take place, and also reflect how data and information about statistics or scientific findings or organizational data can be communicated among people in your organization and to others outside of it. Data visualization. An important part of data communication is data visualization. And notice that I'm using these terms here interchangeably, data and information. So information communication, data visualization, information visualization is pretty much the same thing. Benefits of data visualization: communicate information quickly. You can summarize large data sets into easily understandable graphics. So generally to improve understanding, improve memory and recall of the information. Data visualization builds on cognitive capacities for understanding patterns. Colin Ware, which is a famous guy studying and writing about data visualization, called these pre-attentive attributes. So these are the attributes that are readily recognized by the human mind. So things like orientation, you know, something vertical, what's the length, what's the thickness, size, curvature, shape, added marks, enclosure, and so on, color, spatial position. We're not going to explore this topic in detail here, but once again, broad overview and introduction of some aspects of data visualization. There's this nice little report here from Fusion Charts that we share with you also that shows how the different examples, the different kind of graphics that we usually can easily render or develop in our data science and related work relate to pre-attentive cognitive patterns. So high, low, and in between with the bar charts going up, going down, and remaining flat can be easily observed. Steep and gradual, steepness and graduality, if we can turn that into that kind of word. Non-intersecting, intersecting, of course, we can visualize this kind of patterns. Symmetrical and skewed, wide and narrow, steady and fluctuating. So I guess this is steady and this is fluctuating. With this kind of patterns we can observe. Random and repeating, straight and curved, clusters and gaps, tightly and loosely distributed data points, normal and abnormal. Of course, nowadays, data visualization also is often interactive and maybe responsive. Now I have an image here from a Wall Street graphics on tracking national unemployment. And this one here is just a screenshot. So it's not actually interactive, but if you go to the original site, you can interact with it. There's a lot of information here that they can put at once. So this makes it an interesting and sophisticated graph. I don't really know how much you can kind of learn just by looking at it, but some things are obvious. You can see that the employment is mostly growing. So sectors are rising, right? It's mostly green rather than below zero. So below zero is sectors falling. So there are more sectors rising than falling. But for you to see which sectors these are, you do have to go and actually go with the interactive graph and see what they are. So some neat stuff over there. Data visualization communication is a huge part of the data science life cycle. And so we wrap this up here.